Okay, now one type of problem is that we're taking samples and as regards a mean or an X bar. Another type of problem is that we're trying to find out the sample proportion. For instance, if you wanted to know um, if it was election season and you wanted to know what proportion of the population supports candidate X, that's a proportion. We want to find out, what percentage. So, for instance, I was just looking on the TV today, and it said that they took they took a survey and said that President Trump's favorability rating has gone down to 43%. What that means is that someone took a survey, took a sample of all people in the United States, a random sample, and asked them if they approve of the job that President Trump is doing. And some proportion said yes, they do approve. And that proportion was 43%. Okay, so it's the same kind of problem as we did with a mean, but instead of using a mean or an average value, we're trying to find a proportion in the sample. So it's really pretty much the same thing except for the computation of the sample standard deviation. So let's look at problem 28 in your book. And it's a simple problem. It says a population proportion is 40 or 0.4, 40%. Okay, so 0.4, 40%. That's the population proportion, or P in the standard error formula. Okay, and so then we want a complement of that proportion. So if we're using a presidential approval rating, if the president has an approval rating or 40% of the people approve of the job he's doing, the complement would be 1 minus that, which is equals 1 minus that, or obviously zero point 0.6. All right? So we want to find out within a margin of error. It gives us a margin of error in the problem plus or minus 0.03. So that would be our standard, our margin of error, 0.03. So we want to know plus or minus 3% or 0.03, okay? And the sample size in this problem is 200. So that's relevant. We need to put that in there. Now I need to calculate the sample standard deviation, or the sample error. And if you look in your book, that's the formula that says that the standard error, or the sigma of the population, equals the square root of p times 1 minus p over n. So that may sound complicated, but it's really very simple. So it's just equals the square root of p times 1 minus p divided by n, which is the sample size. Okay, and that's going to be C8. Okay, so 0.0346, that's our sample standard deviation, or our standard error. Right now I want to figure out what would my minimum P bar be in this problem. Well, it would equal my expected P, which is 0.4. So obviously, if 0.4 is the population proportion, or we're assuming that it is, then when we take a sample, we would expect P to be 0.4. So it's this minus 0.03. Okay, and the maximum P bar would equal the expected p-bar plus the margin of error. So I'm looking for, in my sample, I want to know the probability that the population proportion is 0.4 if I get some sample proportion between 0.37 and 0.43. Okay? All right, now again, I want to find the probability that the sample p-bar would be less than 0.43 and the probability that the p-bar would be less than 0.37. Then I just subtract one from the other. I'll find out the probability that p-bar, I'm sorry, this should be p-bar, let me change that. P-bar is between 0.37 and 0.43. All right, so we're just going to use norm dist again. Oops, keep on pressing the wrong key. And in this case, x is 0.43, okay, comma. The mean is the expected p, comma. Standard deviation is the standard deviation here, and cumulative is true. Okay, I'm going to do the same thing with p-bar 1 equals norm dist. X is this one, mean is this one, standard deviation is this one, and cumulative equals true. All right, same thing. I want to know what the probability that the sample p-bar would be between 0.37 and 0.43. If the population p is actually 0.42, it would just equal the one minus the other. Sorry. Okay, so that's the answer to part A. What's the probability that the sample p-bar is between 0.37 and 0.43 if the population proportion is actually 4 and the probability is 0.61 or 61%. Well, that's not super high. Then part B says, well, what if the margin of error is 0.05? So I'll just change this to 0.05 and everything else will recalculate, which is the glory of Excel. Okay, so now the proportion goes up to 85%. So I'm just going to copy that down here. 0.8511, and then I'm going to change this back to 0.03. All right, and that's your, those are the answers to this problem. So you can see as my margin of error is smaller, the probability decreases. If my margin of error is bigger, the probability increases, which, you know, makes perfect sense. So those are the two types of problems you'll have in Chapter 7.